Okay, so we're going to get started here. The first part of this, we're just going to give you some vocabulary so we can all be on the same page with some of these words here. All right, so to start, we're going to ask you some questions to ponder. So what we want you to do is we want you to look at this. We'll go through them real quick. I'm going to pause, then you should pause the video so you have a chance to think about it, come up with some answer, and then we'll talk about some of the details here. So what's the greatest engineering accomplishment of the 20th century? How do newer technology accomplishments compare to those throughout history? How does technology impact the world? What is the difference between innovation and invention? And why does engineering societies develop standards? All right, so we want you to pause the video, think of some ideas, and then we'll get back to it. All right, did you think of a good one? Now, for the first one, what is the greatest engineering accomplishments of the 20th century? Is there a right answer? Well, of course. No, there isn't. No. So you could have picked a lot of different things. You could have picked the electric toothbrush if you wanted. You know, your dentist would be happy about that. At least 9 times out of 10, they say. How do newer engineering accomplishments compare to those throughout history? Well, to be fair, they're just different. Okay? Are they greater in scope? You could argue that some of them are greater in scope than others. They're all going to be so different. So they had more constrictions back then, but they were sometimes less fancy accomplishments, right? But you can't do an apples to apples comparison really between now and 5,000 years ago. How does technology impact the world? All right, here's where we're getting into some interesting stuff. So when we're talking about technology, ooh, how does it impact the world? Well, it should make the world better. Now, better means something else, right? Well, it's an ambiguous word. So when we say make the world better, what do we mean by better? So it could be easier. A task could become easier. It could become more efficient. Or it could become faster. It all depends, any one of those things is what the goal of technology is to do. All right, here's one we should know. What's the difference between innovation and invention? Let's start with invention here. If you come up with invention, you come up with something new. So when you invent the cotton gin, what you invented is some new device that pulls the seeds out of cotton or whatever you made. All right, so it's it could be an object, or it could be a process. Either kind of thing. So you could invent a process, discover a process. We're mixing, it's just semantics for that, but either way. Whereas an innovation is an improvement. Okay, now there is some overlap here. There's some gray area. So an improvement, you're taking something that already exists and you're making it better. Already exists. So let's say that you have homework assignments every day, but then Mr. Keeney comes up with a way where you can turn them in online. Crazy, huh? That could be an innovation. It's not invention because, well, that already existed, but I'm applying it to something new and better. Okay, why do engineering societies develop standards? Well, because they have shared values. Okay, what kind of values do they have? Well, we're going to talk about those tomorrow. So, but to give you an example here, we want everyone to have some ethics. All right, ethics are important. You don't want to build your machines out of the bones of children, for example. That would be a bad thing to do. So there are some ethics that are involved to make sure that no one is doing something too sinister. Okay. So what we're going to talk about here is the ABET, which is the Accreditation Board for Engineering and Technology, how it defines engineering. What's an engineer? It's the profession in which knowledge of the mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways of use, economically, the materials and forces of nature to the benefit of mankind. All right, there's a lot there. Let's unpack it piece by piece. So it's a profession in which knowledge of mathematics and natural sciences. Okay, so this is what you'll be using, math and science. In case you haven't figured it out yet, we did a lot of math and we did a lot of science. But there's a lot of ways to get those skills. You could be studying, you could get them through trying things out, experience, and you could be practicing. That's what we're doing right now. You are going to be studying, and soon you're going to get experience from practicing. You're going to do some assignments. All right, it's applied with judgment to develop ways to use economically the materials. So we're going to use things, we're going to use them economically. What does that mean? It means we're going to not waste things. We're going to use things effectively, the materials and forces of nature for the benefit of mankind. So materials, so you don't waste things, recycling kind of stuff. And forces of nature, like electricity or wind or any kind of energy to help mankind out. Now, helping benefit of mankind is very vague. There's lots of ways, okay? So it could be something car related, it could be a rocket, whatever. There's lots of ways to benefit the world. So an engineer, we're going to talk about engineers, a person who designs products, structures, or systems to improve people's lives. Now, between these three things, you got pretty much everything. Systems could be the way something is done, for example. So if you design a product, could be digital even. Okay, mathematics is the language of science, energy, and technology. Right, in case you didn't know, math is a good thing. Engineers use math to describe objects great detail, and mathematical models can test designs without actually building them. Yeah, so that's why we're going to use simulations for some of these things. That's why we do SolidWorks, because the models can test them without actually having to make the physical objects first. Engineers use scientific principles to guide their design, right? That's why we talked about science. Do you remember when we learned about all that electrical stuff? That's all scientific principle oriented. And now you know, well, hopefully, how those transistors and things worked. Or you'll have to remember them eventually, right? Engineers can work in teams, and planning and design is a large part of their work. So we've done lots of teamwork here, and we plan our design, right? Lots of planning. You're going to be having to design something in SolidWorks, hopefully, when we come back, but we're going to work on that later. Engineering is a form of problem solving. Engineers work in teams because different people can have different skills, right? That's important because maybe someone has more experience in one area, can look at the problem in different ways. An engineer must look at a problem, criteria, and solution constraints. What are constraints? Give you the short version today. We're going to talk about it more tomorrow. Constraints are restrictions. All right, sometimes you have restrictions on what you're doing. You can't just make something with no rules. Engineering involves design and construction, so sometimes you have to design things, sometimes you have to know how to build it, right? We've done both of them with different things throughout the year. Engineering is iterative. What does iterative mean? It means it's repeatable. All right, so you can do it over and over again, and then someone else can try it, and someone else can get the same results. Okay, so these are the basics of engineering that we have here. So you will notice that we have done these in lots of different forms throughout the class. And what we're going to do tomorrow is we're going to look at some more vocabulary that's within the specific process of engineering. This is more of a general what engineers do. All right, sounds awesome. We'll see ya on the tomorrow.